Hello and welcome back to episode 13 of Chemistry in 15 Minutes or Less. My name is Audra, and this is part 2 of the review video, part 6, Lewis-Dot structures. And just for a quick refresher on where we left off, we talked about single atoms, monatomic ions, simple molecules, multi-atom molecules, and multi-bonds. So now we are on number 6, resonance structures. Now these are called resonance hybrids, and these are what happens when there are multi-bonds. For example, ozone is called O3, which, as you know, oxygen likes to bond with just itself as O2, but what happens when there's 3 of them? Now, each oxygen needs to have its full valence shell, so I'm just going to go ahead and dot some stuff on to show you what it's going to start to look like. Now you see, if I do this, every oxygen has its full valence shell, except this oxygen in the middle that's bonding 3 times. Now technically that doesn't happen in nature, because you also could put, if the molecules stay in the same order, the double bond on the other side. Which means you have to draw both of these and the arrow in the middle for you to get full credit for the question. Why? What's the point of that? Because what it really looks like is something like this. The double bonding is shared. The electrons are delocalized. But you can't draw that. That's not the point. You have to draw the resonance structures and the arrows, so you have to draw every available resonance structure. If you can put the bond in 6 different places, draw all 6. The reason we went over that first is so we can go on to 7, which is polyatomic ions. Now, for our example for polyatomic ions, let's do nitrate, which, as you'll notice, has a charge like when we did monatomic ions. So I'm not going to go through the table with you, I'm just going to draw this for you. Here you have oxygen. Nitrogen can bond 3 times, double bonded to a nitrogen, single bonded to another oxygen, single bonded to another oxygen. Now, if you'll remember, nitrogen is only supposed to form 3 bonds, and it doesn't like to bond more than once because that requires taking this lone pair of electrons and using it for a bond. Which means it's got a resonance structure. Which means you can also draw it this way, where these are the same atoms in the same order. The double bond is over here. Or, in the final case, the double bond is down here. Now, since these are technically full, you have to add the charge the same way you do it to the simple monatomic ions. And the central atom tends to be the less electronegative, which in this case would be nitrogen, since you have 3 oxygens. Now I know I'm glossing over that, but that's just because I couldn't fit this in the last video, and there's not too much left. All that's left are exceptions. Now, there are a couple of different types of exceptions we need to talk about. The main types of exceptions are when there is an odd number of electrons. Now, in order to go through these, let's take an example of nitrite, which you'll remember, nitrogen has an odd number because it has 5 valence electrons, while oxygen each have 6. So when you draw it, in order for everything to have its full valence shells and its double bonding, it does have a resonance structure. Sorry, that's an extra electron. Nitrogen has only one valence electron left, which means you just have to draw it that way. It's got an extra one at the bottom, but that's only if when you do the table, you have an odd number. Now another example is when you have less than an octet. Now this would be something like when you have boron or something towards the beginning of the table, or beryllium. Those are the only two elements it occurs with. So let's say you have boron trifluoride. In order to draw that, you have fluorine. Sorry, I don't know why this came together. To boron, to another fluorine with its full shell, to another fluorine with its full shell. So boron only has 3, so it doesn't get anything up here. It doesn't have technically a full shell. It just ends up like that. And the final exception is the opposite, more than an octet. This tends to occur with everything around phosphorus on the table. So for example, if you have phosphorus pentafluoride, just using this as an example, in order for it to bond, phosphorus has to break up and bond 5 times. To its different fluorines that out here all have their full valence shells. I don't know why I added that extra electron, sorry. My tablet's acting up. It will break up to have 5 bonds, even though it technically will say it only needs 4. You have to be able to get all 5 fluorines on the table. Now to quickly sum up what we covered, we've gone over atoms, monatomic ions, simple molecules, multi-atom molecules, and multi-bonds in the last video, which I will leave linked. And now we've gone over resonance structures, polyatomic ions, and some exceptions to our rules. And with that, that concludes part 2 of episode 13 of Chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channels for more videos on chemistry review, as well as part 1 if you missed it. As always, I hope this helps, and have a great day.